All right, in this video, we're going to talk a little bit about plate boundaries. So there's a section on your study guide where it asks for you to draw plate boundaries and identify the landforms that occur there. So we're going to go through divergent, convergent, and transform boundaries. But keep in mind, you should be using your plate tectonics notes. We've already taken notes on this. So this shouldn't be the first time that you've seen it. Use your notes to help you. So divergent boundaries, we get two different kinds, and it depends on where you're located, what kind of crust we're dealing with. A mid-ocean ridge happens, spoiler alert, in the middle of the ocean. A rift valley occurs in the middle of land. So that's the main difference between these two pieces. But because they're dealing with different types of crust, we get different types of features. So for a mid-ocean ridge, what we got going on is we got an oceanic plate being pulled to the left and an oceanic plate being pulled to the right. So as these plates spread apart, it leaves this kind of gap in between. And that's where magma blah, 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 makes its way to the surface. And you can see in this picture that this middle area is elevated. And that's what a ridge is, like a mountain ridge. That's an elevated structure because this magma that keeps seeping out just keeps building on itself. Now, this isn't the same thing as a volcano. Volcano is usually one location where magma seeps through, whereas this is going to be a whole line, just a massive underwater mountain range, because of the whole plate that's being spread apart. So if you were trying to draw this on your own, it's not as hard as it may seem. The way we start this is we've got one oceanic plate, and we've got another one, and they're being pulled apart sideways. So doot, 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 because it's a divergent boundary. So they're being pulled apart sideways. I'm gonna throw some water on here. Shows me that it's oceanic crust. And then finally, as they get pulled apart, blah, blah, oh, that's still blue. Blah, 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 blah. That would now be our magma, and then some gets deflected sideways too. That's our magma that seeps its way to the surface. That's a mid-ocean ridge, where we've got two plates being pulled apart and magma that seeps up in the middle. Boom, mid-ocean ridge. Divergent boundaries move apart. Mid-ocean ridge happens in the middle of the ocean, creating this tall ridge of fresh crust. Brand new, very constructive event. Now, on the other hand, we've got our rift valley. Now, keep in mind, our continental crust is way thicker than our oceanic crust. So because this crust is super thick, as it gets pulled apart, it just kind of slouches the ground down. We actually call it slumping. So instead of building up land here, it's actually bringing it down a little bit. So rift valleys occur on land, and as they get pulled apart, a really easy way to draw this one is you take your fun little marker and you start, and then it slumps down. And we've got the same thing going on the other side. So that's our rift valley. This is being pulled. This is being pulled. It's not thin enough for magma to make its way up to the middle. It's just land that's slouching down as it gets pulled apart. That's divergent boundaries. Yeah. Oh yeah, by the way, earthquakes occur here. So if it ever asks for a landform, mid-ocean ridge is a landform. Rift valley is a landform. Earthquakes are events, and they're going to happen at every boundary. So earthquakes happen when the plates are shifting and adjusting. That's why they also happen at both of these boundaries. Now let's talk about our convergent boundaries. So these are, we got three different kinds, and it all depends on what kind of crust is involved. Because just like our mid-ocean ridge and our rift valley, the crust matters. It changes what kind of landform we get. So this is an example of an oceanic convergent boundary. Now remember, converge means to come together. So in this particular scene, what we got going on here is oceanic crust slamming into more oceanic crust. We're focusing on this realm right here. Now as they collide, we get a bunch of different features. And most of that is due to this subduction zone. The denser oceanic plate will dive under the less dense one. And that subduction causes tons of stuff. As one plate dives under the other, it pulls down the other crust, and it creates this really deep space that we call a trench. The friction between the plates causes the rock to melt. And remember, what do hot things do? They rise because they're less dense. So we end up getting these volcano islands, those volcanic island arcs. And then we also get earthquakes. So if you were trying to draw this on your own, what you could do is you're gonna always start with the subduction zone. This is underwater, so I'm gonna blip, 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 water all on each side. I'm gonna add some arrows so I know that this one is colliding into this one. And I'm gonna label some stuff. So right here, this really deep location, that's our trench. As one plate dives under the other, it pulls the other plate down. It like pulls it down. That's the trench. It's a really deep area. So mid-ocean ridges are really tall underwater, and trenches are the opposite. They're being pulled down at subduction zones. So they don't even occur at the same type of boundary. Trenches occur at convergent boundaries. The friction between the plates causes melting of magma, and hot things rise to the surface, causing us to get a volcano. And then, of course, what happens at every single boundary? Earthquakes. So if we're going to talk about the landforms that happen here, trenches are landforms, volcanoes, landforms, and then our earthquakes are our events that happen here. So that's our oceanic convergent boundary. The next one we're going to talk about is our oceanic continental boundary. So we're going to have a lot of similar features, but we're also going to get some added features because we now have continental crust, which is a little bit thicker than our oceanic crust. So we have the same subduction zone happening here. Our oceanic crust dives under because it's more dense than our continental crust. And we're going to end up getting a lot of the same features. We still get trenches, we still get volcanoes, but now we also get mountains. And the reason why we get mountains is this continental crust is really brittle. And as it slams into the continental crust, it kind of smashes almost like a car pileup where the ground just crushes into each other and it causes it to build up as that happens. And as this goes under, it forces that land upward a little bit. So our oceanic continental boundary is going to have a lot of similar features, but we're also going to have new ones. So if I were to draw this, doing the wrong thing. There we go. I'm going to have one plate diving under the other. I'm going to have my trench, but now this land is going to be a lot taller. Because if it wasn't taller, then water would be over all of it. But if I have oceanic crust, I should have taller land, continental crust, and shorter, where my water can be on top. These plates are diving into each other. And it creates a lot of the features we saw before. This place where they're scraping into each other and pulling it down, that is our trench. This event here where we have this friction causing it to melt. Hot things rise because they're less dense. Boom, boom. We get our volcano. And then, of course, our new feature is going to be boom, 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 boom. Our mountains. And that's because the continental crust is piling up on itself. So our landforms are trenches, volcanoes, mountains, and then of course, because it's a boundary, we are also going to get earthquakes, 100%. Now our final one is continental. These are convergent boundaries with just continental crust. So you're going to see some different features here. First of all, there's no water because we're in the middle of land. So we got continental crust slamming into continental crust, and you're going to notice there's no volcanoes here. And that's because the continental crust is way too thick. There's just not enough heat and magma to go all the way through these layers. But we are going to have these mountain ranges because, again, when we slam this crust together, it just piles up on itself. So it just continues to slam, it piles up. And then if we were to draw this ourselves, since we're in the habit of it, we're going to have one plate diving under the other, one plate getting pulled in. Notice we don't have a trench this time. The reason we don't have a trench is because there's not a huge density difference between these two things. The only thing we get where they meet are really tall mountains. So mountains, inland mountains, are our landform here because we have continental crust going into continental crust. And of course, what we get at every single boundary, earthquakes, 100%. So at continental convergent boundaries, we get mountains, that's our landform, and earthquakes, that's our event. And our final boundary to talk about is our transform boundary, which is kind of a piece of cake. You know, the only thing that happens here is earthquakes. And all we have are two plates that are kind of grinding past each other. One's not moving up, one's not moving down. They're not pushing together, they're not coming apart, they're just moving past each other. So if you were to draw this, you really could draw a very simple drawing and just draw plates that are moving past each other. Any way you show me that, you're good to go. So we've got plates that are just moving past each other. We don't get a lot here, except of course we get earthquakes. Because earthquakes are always going to happen anytime we have those plates bumping and moving against each other. Again, all of this stuff is in your plate tectonics notes. This shouldn't be news to you. But if you wanted just to hear it again, see it again, that's one way for you to see it. Ooh, next video.